Today, I will be discussing angles and their measures. Angles and their measures. In plane geometry, we define an angle as a figure formed by two rays having a common endpoint. Trigonometry defines an angle in terms of rotation. An angle is a figure formed by the rotation of a ray about its endpoint from an initial position to a terminal position as illustrated in the figure below. So consider the figure here below. We have the initial side and the terminal side. As you can see in figure 1, the vertex is at O. We have here point A and point B. So as you can see here, ray OB is the terminal side and ray OA is the initial side. The amount of rotation is the measure of the angle. The endpoint of rotation is the vertex of the angle. In the figure at the right, the vertex is at O. The initial position of the ray is ray OA, which is the initial side, and the terminal position of the ray is ray OB, which is the terminal side. To draw a trigonometric angle, it is important to include an arrow curve from the initial side to the terminal side in order to show the direction of the rotation. The direction indicates whether the angle is positive or negative. We call an angle drawn in a counterclockwise direction as a positive angle, while an angle drawn in a clockwise direction is a negative angle. Consider the figure here below. We have the initial side to its terminal side. As you can see, the direction is a clockwise direction. So this is actually a negative angle. As you can see in figure 1, take note, angle beta is a negative angle. Consider another figure here. From initial side to its terminal side, the direction is a counterclockwise direction, which indicates a positive angle. So as you can see in figure 2, take note, angle phi is a positive angle. Angle measures. There are three standard methods of measuring an angle. Number 1, we have the revolution system. In this system, the number of rotations or the fractional part of rotation is counted from the initial side of an angle to its terminal side. One full rotation is equal to 1 revolution. Number 2, we have the sexagesimal system. In this system, the basic unit is the degree. One full counterclockwise rotation equals 360 degrees. The degree is subdivided into 60 minutes, and each minute is divided further into 60 seconds. That is, 1 revolution equals 360 degrees, 1 degree is 60 minutes, 1 minute is 60 seconds, 1 degree is 1 over 360 degrees revolution, and also 1 degree is equal to 3,600 seconds. Number 3, we have the radian system. This system provides a link between the measure of an angle and the length of an arc of a circle. Example number 1. Find the measure of the angle in revolutions and degrees for each given rotation. Sketch the angle. 1/2 rotation counterclockwise. This is just the same as 1/2 revolution, which is simply equal to 1/2 of 360 degrees. Simplifying further, this is simply equal to 180 degrees. Consider the figure below, a straight line. So we have here a straight angle, or we can name this angle as angle AOB, which measures 180 degrees. 2/3 rotation clockwise is the same as 2/3 revolution, or simply equal to 2/3 times negative 360 degrees, since it is a clockwise direction. This is simply equal to negative 240 degrees. Consider the figure below. So we have here angle AOB in clockwise direction, which measure negative 240 degrees. Fractional degree. We express the fractional part of a degree in two ways. Number one, decimal form. Divide the numerator by the denominator to express a fraction as a decimal. For instance, 1/2 of a degree is 0.5 degrees. Number two, minutes and seconds form. There are 60 minutes in 1 degree and 60 seconds in 1 minute. For example, 5/8 of a degree is 5/8 degrees times 60 minutes over 1 degree. This is just equal to 75 minutes over 2, or 37.5 minutes. 37.5 minutes is just equal to 37 minutes plus 0.5 minutes times 60 seconds over 1 minute. This is just equal to 37 minutes and 30 seconds. Hence, 5/8 degrees is just equal to 37 minutes and 30 seconds. Let us consider some more examples. Example number 2. Convert the measure of the angles in decimal degrees to corresponding minute-second measures. Letter A, 20.15 degrees. 20.15 degrees is just equal to 20 degrees plus 0.15 degrees. Converting 0.15 degrees into minutes, so we multiply 60 minutes over 1 degree, so that the degree will be cancelled out. This is just equal to 9 minutes. Thus, 20.15 degrees is just equal to 20 degrees and 9 minutes. Letter B, 155.37 degrees. This is just equal to 155 degrees plus 0.37 degrees. Converting 0.37 degrees into minutes, so we multiply 60 minutes over 1 degree, so that the degree will be cancelled out. This is just equal to 22.2 minutes. Now, converting 0.2 minutes into seconds, we multiply by 60 seconds over 1 minute, so that minute will be cancelled out. Simplifying further, this is just equal to 12 seconds. Thus, 155.37 degrees is just equal to 155 degrees, 22 minutes, and 12 seconds. Example number 3. Convert the minute-second measures of the angles into decimal degrees. Letter A, 28 degrees and 45 minutes. 28 degrees and 45 minutes is just equal to 28 degrees plus 45 minutes times 1 degree over 60 minutes, so that minute will be cancelled out. This is just equal to 28 degrees plus 0.75 degrees. Thus, 28 degrees and 45 minutes is the same as 28.75 degrees. Letter B. 176 degrees, 30 minutes, and 18 seconds is just equal to 176 degrees plus 30 minutes plus 18 seconds. Converting 30 minutes into a degree, we multiply 1 degree over 60 minutes. So that minute will be cancelled out. 30 over 60 is simply equal to 0.5 degrees. And since 1 degree is equal to 1 over 3,600 seconds, then 18 seconds times 1 degree over 3,600 seconds, seconds will be cancelled out. This is just equal to 0.005 degrees. Thus, 176 degrees, 30 minutes, and 18 seconds is just equal to 176.505 degrees. Using the scientific calculator, most scientific calculator have the function key, degrees, minute, and seconds. This key is used in converting decimal degrees to minutes and seconds form. Be sure when using a calculator, you are in appropriate mode. This means that when the angles are in degrees, the calculator should be in degree mode. Angles in standard position. An angle is in standard position when it is drawn in rectangular coordinate system with its vertex in the origin point O and its initial side along the positive x-axis. Consider the figure below. We have the initial side to its terminal side, vertex at the origin. This is actually angle beta. The initial side is along the positive x-axis with vertex at the origin. Therefore, we can say that angle beta is in standard position. Angles in the four quadrants. When theta falls from 0 degrees to 90 degrees as in figure 1.1 to the right, the angle theta is a first quadrant angle. For instance, we have theta is equal to 45 degrees. So, as you can see, the terminal side falls in the first quadrant. So, therefore, angle theta is a first quadrant angle. When theta falls from 90 degrees to 180 degrees, as in figure 1.2 below, the angle theta is a second quadrant angle. Consider the figure below. So, we have the terminal side is in the second quadrant. So, angle theta, which is equal to 120 degrees, is a second quadrant angle. When theta falls from 180 degrees to 270 degrees, as in figure 1.3 below, the angle theta is a third quadrant angle. Consider an illustrative example. Theta is 210 degrees. As you can see in the figure below, the initial side is along the positive x-axis and the terminal side falls in the third quadrant. So, angle theta is a third quadrant angle. When theta falls from 270 degrees to 360 degrees, as in figure 1.4 below, the angle theta is a fourth quadrant angle. For instance, we have 330 degrees. So as you can see here, from the initial side, the terminal side falls in the fourth quadrant. So angle theta is a fourth quadrant angle. Take note, if the terminal side of an angle lies in either x or y axis, the angle is a quadrantal angle. For instance, we have 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Let's have a practice drills. Perform as indicated. 1/4 rotations counterclockwise. So, find the measure of the angle in degrees and revolution. Take note, 1/4 rotations is the same as 1/4 revolution. Since it is a counterclockwise direction, this angle is a positive angle. 1/4 times 360, this is simply equal to 90 degrees. 5/6 rotations clockwise is a negative angle since it is clockwise direction. 5/6 times negative 360 degrees is simply equal to negative 300 degrees. Take note, 5/6 rotations is the same as 5/6 revolution. 3/2 rotations counterclockwise. This is a positive angle since it is a counterclockwise direction. 3/2 times 360, this is simply equal to 540 degrees. Take note, 3/2 rotations is 3/2 revolution. 2/9 rotations clockwise is a negative angle since it is a clockwise direction. 2/9 rotations is equal to 2/9 revolution. 2/9 times negative 360, this is simply equal to negative 80 degrees. 7/12 rotations clockwise is a negative angle since it is a clockwise direction. 7/12 rotations is equal to 7/12 revolutions. 7/12 times negative 360 degrees is simply equal to negative 210 degrees. 6 to 8, convert each measure of angle in decimal degree into the minute-second measures. 50.125 degrees. This is just equal to 50 degrees, 7 minutes, and 30 seconds. 27.775 degrees. This is just equal to 27 degrees, 46 minutes, and 30 seconds. 96.345 degrees. This is just equal to 96 degrees, 20 minutes, and 42 seconds. 9 to 10, convert each angle measure into decimal degrees. Round off your answers up to 4 decimal places. 15 degrees, 45 minutes. This is just equal to 15.75 degrees. 89 degrees, 15 minutes, and 25 seconds. This is just equal to 89.2569 degrees. 11 to 15. For each given angle, determine which quadrant does the given angles lies in the Cartesian plane. Otherwise, it is a quadrantal angle. Theta is equal to 84 degrees. The terminal side lies in the first quadrant. So this is a first quadrant angle. Theta is 258 degrees. The terminal side lies in the third quadrant. So this is a third quadrant angle. Theta is 170 degrees. The terminal side is in the second quadrant. So this is a second quadrant angle. Theta is 341 degrees. The terminal side is in the fourth quadrant. So this is a fourth quadrant angle. Theta is equal to 270 degrees. Therefore, it is a quadrantal angle.